right, welcome back. What we are going to be learning today in this lesson is about linear equations. So what is a linear equation, what is slope, and what is y-intercept? So I'm going to show you what that looks like on a graph and just a standard equation. You should be able to define linear when you're done with this. You should be able to match a linear equation to its graph. So if I give you both, can you pair them off? You should be able to write a linear equation given the slope and the y-intercept. So first things, what in the world is linear? We've talked about this before. Remember, chop off the AR and you have the word line. So it really just means extending along a straight line. If you can connect all the points in a nice, beautiful line, I don't care what direction you move, it is linear. Think of that as constant movement. There is no fluctuation in how it changes. So if you're adding 3 once, you're adding 3 over and over and over again, etc. This is the form that we are going to start by working in. So this is slope-intercept form, y equals mx plus b. You should have seen this in Algebra 1, but we're going to do a short review on this. Remember the x and the y, that's just your x and y on a graph. So your x-axis is the horizontal line, straight line, and the y-axis is the up and down vertical. So if we look at the last page, here is your x-axis. Here's your y-axis. So if I say x is, if I say x is 1, y looks like it's about, I don't know, 2.2. If I say x is 3, then y is 1. If I say x is 6, y is -1. So it's just values on the x and the y-axis. That's what x and y means. The m and the b are the important pieces though. So m over here, that is your slope. Think of that as what is changing and how fast it's changing. And b is the y-intercept. So y-intercept, think of that just like you would in football, interception. So say you are standing up here, you're the quarterback. You're standing up here and you want to make a throw to your player that's running down the field who's going to end up here by the time you release the ball. But unfortunately, we've got, let's say this is a Lowell player. He jumps up and snags the ball out of the air before you can get it to your player. You call that an interception. So right here is where the interception occurred. It specifically asks for the y-intercept. So the y-axis is this line here. So where does the y-axis intercept your linear equation? And that's at this point. So in other words, you could say if x is 0, what is y? Well, in this case, it is 3. So the y-intercept is 3. It's just where does the y-axis and your line hit each other? Where does it collide? Just like in football. What then is slope? So think about this. If the intercept is where the ball were, if intercept is where the ball was intercepted, then slope is more how fast and how far your player moved. So in order to get from point A to point B, you have to make some sort of movement. I don't care if it's a zigzaggy, straight line. Since we're talking about linear, run a straight line. How fast is your player moving and how far did your player run? That's kind of what slope is. You may have heard it as finding it by doing rise over run. So how far up and down did your player move in comparison to how far left and right? So rate of change, that's represented by the variable m. So here's some equations here. We have y equals 2x plus 4. You should be able to, if given an equation, tell me the slope and the y-intercept. Well, the rate of change, that's always different depending on where you want to look. So where do you want to know your player is after 1 second versus 10 seconds? So how far can your player run? So the rate of change is always next to the variable. So in this case, my slope is 2. The y-intercept is 4. So think of that as the y-axis. So your vertical line, your linear line is going to cross it at the 4. In this equation here, -3 is your slope, and your y-intercept is +1. This one's flipped around a little bit, that's fine. But remember, whatever is attached to the x is your slope. So in this case, it is a -4. Be very careful. So this minus sign is kind of attached to the 4. So it is a -4 slope. And your y-intercept is just that extra piece over here, which is a +5. This final one, notice how y is not by itself. You got to be careful. Y needs to be alone before you can tell me the slope and the y-intercept. So get rid of this 2. You learned this in our previous lesson. So to get rid of a 2 that's being multiplied, you have to undo that with division. So you got to divide by 2 on both sides. When that happens, the 6x turns into 3x, and the 8 turns into 4. Dividing by 2 does that. 6 divided by 2 is 3. 8 divided by 2 is 4. So that's how I got a slope of 3 and a y-intercept of 4. I just have another example like that. So if it's not in slope-intercept form, how do you fix it? We need to get y by itself and everything else on the other side. So we need to get rid of this positive 12x and this 3. Well, to get rid of a positive 12x or a plus 12x, remember they're glued together, move it as a whole. So let's just subtract 12x from both sides. So if we subtract 12x from both sides, it'll look something like this. So we have our minus 12x, and then we just need to get rid of this 3. So to get rid of a 3, you have to divide by 3 on both sides. 9 divided by 3 is 3. -12 divided by 3 is -4. So you can leave it like this, y equals 3 minus 4x, but again, I shifted it a little bit so that my variable was in the front. So I just moved the -4x up front and the positive 3 in the back. So in this case, the slope is -4 and the y-intercept is 3. Okay, so that's kind of all I have for you today. You should be able to differentiate between slope and y-intercept. We're going to look more on graphs in the next video, but go ahead and check any videos that you need extra assistance in the description below, and let me know if you have any questions.